So the first one, interpret geometrically the vector equation of R equals to A plus TB, where A and B are constant vectors and T is a parameter. I think this is pretty okay. Just know that now this is a position vector. If this means adding a dimension, adding a direction vector, adding a dimension, right? So in other words, this is position. Okay, you take a point, you add a dimension, it's a line. So R vector equation of this is all the variable point R. Okay. Contain is the variable point. Position of position vectors. On the line which passes through position vector A and parallel to direction vector B. Okay, so that is a line equation. So these are the variable points of position vectors on the line which passes through position vector A and parallel to direction B. I think that's pretty okay. R is the position vectors, are the variable points. You can draw. You can draw if you want. So because it just asks you to interpret. So if you want to draw, you can just draw it out. So it's A and then this is B. That lah. So this is O. Like that. So you take a point A, you add a direction B, there will be your line, all the variable points. R are the variable points of the position vectors on the line. So this one, not an issue. I think the second part is 3 marks, so you have to be careful. R dot n equals to D. We obviously know that this is a vector equation, but the twist is essentially n is a constant unit vector. Unit vector means that n unit vector is actually mod n equals to 1. Okay, unit vector, and unit vector had this property where n in itself is equals to unit vector. Vector of a unit vector is unit vector lah. You cannot go as far more unit than a unit vector already. So if you give me a unit vector, I know for sure that is a unit vector. So D is a constant scalar. So stating what D represents. Okay, interpret geometrically. R dot n equals to D. I think for part 2 is 3 marks, shouldn't be an issue, because I think the 1 mark will be quite easy to get, which is the vector R represents all the variable points on a plane, okay, which has a normal vector of n. But now the problem is how to get the other 2 marks. Okay, the other 2 marks comes from how do you explain D lah. How do you explain D? So refer to the summary notes. If you have if say, yeah, I think I'll just write this somewhere. If say you have a plane equation of R dot n equals to K, okay, the shortest distance of plane to origin is what? It's actually equals to K over mod n. Yeah, this is the formula you have to know. So meaning to say, example, if say I got, for example, if say I got example, if I got r dot 211 minus 1 equals to 3, I know that distance, perpendicular distance of plane to origin is definitely 3 over mod 2 minus 1, 1, which is 3 over square root 2 square plus 1 square plus 1 square, which is actually 4, or this is 3 over root 6. Okay, so this is just a recap. How do you derive this formula? You also need to know how to derive, but later I'll show you. But just understand that shortest distance of a plane to origin is just take the constant divided by the modulus n. Okay, so this is important. This is how you derive. Okay, I'm going to draw this like that so that it's easier. The normal pointing upwards. So let's say I point upwards here. This is easier to understand. So say if you have a normal here, okay. So this is R, point R. So in other words, right, I do not know where's the origin. So let's say this is the origin here. So this is like that. Now rationale is I can do it like that. I obviously can do the normal here. But because I want this to be R, this normal is here. I could do it here. This is normal. Do you see that by using magic triangle, right? By using magic triangle, what you do is this is R, because this is n, right? This is theta. This is R dot n unit vector. Just cosine cosine. So you if this is normal, the normal. By using magic triangle, you just take this dot with this one, you get the shortest distance from origin to the plane. Okay. So if they ever ask, you should be able to draw it out. So it's like R dot n unit vector would be the shortest distance. That's how you actually derive this formula here. This formula. Okay. But what is the twist of this question here? The twist of this question here is the D . So like I say, you know that because if n in itself, n is a unit vector, so this will just be this, right? Right. So in other words, right, the shortest distance it will be R dot n over mod n, which is actually 1. So R dot n in this case here is R dot n is D. Okay, so that will be D is D. Shortest distance. The next part would then be you need to explain what is D. So the variable points represent all variable points on the plane which has a normal vector of n, and satisfy the equation. R dot n equals to D . Okay. So but D is actually the shortest distance. D is the shortest distance. D is the shortest distance. D is the displacement. Okay, you realize that it's a displacement because it's the shortest distance of plane to the origin. Okay. Minus D here can be plus or minus. That's the thing. So you if it's plus, obviously this is acute. This is acute. So meaning this is when D is positive, is above this direction. If D is negative, you're looking at this part because the theta would be a obtuse angle. Okay. So when it's acute, everything is So D is positive, meaning it's a displacement from the origin parallel to N. Mod D is the shortest distance, and where D is where D that means positive translation of plane from origin. A positive translation of plane from origin parallel to N, and so the first thing they gave you is give that b dot n is not equal to 0. Solve the equation r a plus tb and r dot n d to find r in terms of a, b, and d. So take note, guys. This is these are vectors. This is a scalar. Okay, so you want to just solve the equation. So it should be the issue. First of all, try and understand what is b dot n not equal to 0. So part 3, b dot n not equal to 0 means what? If b is the direction of a line, then n is the normal vector, right? N is here. If b dot n, this is b, right? First of all, we understand what b dot n equals to 0 will be perpendicular, right? Alright. So in other words, right, if b dot n equals to 0, we are looking at the plane is parallel to line. So when they put a not equals to 0 there, it just means that b dot n not equal to 0 just means plane is not parallel to line. It also means what? Plane and line are intersecting. So the first thing to pinpoint is the b dot n not equal to 0 part. Okay. Yeah. Okay, so let's just go. So you know they're intersecting. So in this case here, you just need to sub the line equation into the plane, right? So part 3, you sub r equals to a plus ev into r dot n equals to d. So that will be a plus tb dot n equals to d. Take note, when you expand this in scalar product, that will be a dot n. This is a scalar, t b dot n. This is also a scalar, meaning you see this entity as a number. This is a scalar, like a number. These are all scalar, like your coefficient and so on. So just take note. See this as scalars. So t will just be d minus a dot n over b dot n. Okay, they are just numbers. There you go. They're just numbers. Once done reading, you sub this t into the line equation. That will be r equals to a plus d minus a dot n over b dot n b. Okay, is this a dot product? No, this is just a multiple. This one, just leave it. You cannot simplify already. Just think about this, right? This over here is just a scalar multiple. So like for example, if I say 3x 2k, okay, k times 2, right? You just, or let's say 2x minus 1 times k, you leave it as 2x minus 1 because it's just a scalar multiple of the vector. So this is it. So this is scalar. This is another number. This is a vector. This is a vector. A vector. Leave it like that. So what you said, the solution, interpret it, solution represents the position vectors of the intersection point between the line r equals to a plus tb and plane r dot n equals to b.